Okay, so today we're going to talk about CRUD applications. So up till now, we have talked about how to get data using REST APIs and using the Spring framework. Yesterday, we talked about persistent data. So how are we going to store data in a database? And today, we kind of throw them all together. So we're going to end up with an application that can do a lot of things. One thing is it's going to store data for us, but it's going to have the similar things that we're used to seeing. So I can come over here. So I am running the finished product of today's guided project. And I just want to show you what's going to happen. So I can do a get. Now we've done gets before using the get mapping, and I can do a get and retrieve some data just like we've done before. That's not that exciting. What becomes exciting is when I can start doing where I can change the data. So let's add so this particular application at the end is going to work with restaurants. Restaurants have a name and address, city, state, telephone number. And then they have a series of menu items that go with them. And there is what's called a one-to-many relationship between restaurants and menus. What that means is every menu item that's listed is only assigned to one restaurant. So if we have multiple restaurants that say serve mac and cheese, well, then there'll be multiple lists for mac and cheese, multiple menu items for those, because every menu item only goes to one restaurant. Now, hopefully, a restaurant sells more than just one item. So we're going to have the restaurant can go to many menu items. So we get a one-to-many relationship, one restaurant to many menu items. A menu item, though, can only go to one restaurant. All right, now let's say, so we've done this. We've done the restaurant. The big thing here is that we've added this many to one relationship. But what we're going to add here is we're going to add CRUD operations. CRUD stands for create, read, update, delete. And so let's add another restaurant. So we could do that now, or we will be by the end of the class period. So let's go to body, and I want to put in the data that I want to add. So remember when, and this is just, you're just watching, there's nothing to follow along right here. So remember when we're returning data, we return data in this JSON format. And we've been doing that. We've been returning data in a JSON format. Well, here we're going to send data to our backend system. So we're sending this data to our system, and we're going to add the Good Eats restaurant. Now, add in the web world is called a post. And so I'm going to post this out there. And it would help if I used the right endpoint. And notice I get absolutely nothing back. That is actually very common with a post. Nothing comes back, except we have this thing that's in our body, nothing comes back. But when you get a response back from a REST API, you have stuff that's listed in body, but you also have stuff that's listed in what's called a header. And if you come to the header, you can see one of the things that's here is how we can look up, it's the URL to look up the restaurant we just created. And that's going to come back in our header. So if I do a copy, I can come over here and look up the restaurant we just added. And there's the Good Eats restaurant that we just added. And they sell a soda and a latte, which is what we said they added. So that's kind of the overview of where we're headed. We can also update data. We can delete data. We can do all the 4 main operations in CRUD. And we'll be able to do that by the end of the class period. We got a lot to do. Let's get started. All right, so I'm just going to close out of Postman. I don't need Postman right now. And I do, though, need all right, you're going to be difficult for me, aren't you? Oh, there you go. So I'm in IntelliJ. I went to New Project, and I'm creating a new project, just like we've been doing. Hang on one second. I forgot to do something first. Okay. File, New Project, Spring Initializer, Java 11. This all looks good. So I'm going to go to Next. And in here, I'm going to add my group ID like we've been doing. I'm going to call it Lambda School. So if I didn't make this obvious, this is a good time to start following along. Yes, I need to make that stick out more. But yes, this is a good time to start following along. We're actually going to create that restaurant project I was just showing you. And I'm going to call it CRUD Restaurants, because we're working with restaurants and we're using CRUD. So I'm going to call it CRUD Restaurants. And I'm going to change the version to 11. Okay, pretty standard so far. I'm going to do a next here. Now, just like we've been doing, I need to add dev tools. I need to add web. There's 2 other things I need to add. We are going to be working with one of 2 databases for the rest of the course. PostgreSQL is going to be the main database that we work with when we go to production on something. Almost everyone that does development in Java Spring for their development work and for all their testing work and everything use an in-memory database called H2. So we need to add the H2 database. What's really nice about the H2 database and the way Spring works, we're going to do all this work inside of H2. We're going to get everything working. It's really nice because it's in memory, meaning that every time you exit your program and fire it up again, your data resets for you. So you can make all kinds of major mistakes and just have everything reset. It works out really well for testing. The other really nice thing is to switch from H2 to PostgreSQL when we're ready to go to production. It's a configuration change. It's not a change in code. So that makes it really nice. So we're going to add H2 to our list here. And then we need some way for Spring and Java to access our database. And to do that, we use something called JPA and Hibernate, Java Persistence API, and then Hibernate. Java Persistence API is the specification, the interface that talks about how we go from Java to our database and back again. Whereas Hibernate is the actual implementation of that specification. And so it's Hibernate that actually takes our Java blobs and converts them to these nice tables and rows and then does the reverse. The nice thing is all of that is bundled into one dependency. So we have added dev tools, web, JPA, and H2. Cool. Let's go on. We've got our list here. And I do want to call it CRUD Restaurants, but I want to save it under my work. Let's see, we've been using class in here, so I want to go find my class folder. And I do want to call it, though, under there, I want to call it CRUD Restaurants. So the folder where I'm going to save my work, the name that I want to save it under. And I know it doesn't exist, so please create it. And I have another project open, so I'm going to open this one in a new window. I do need to enable auto import. So far, this has been like we've been doing with the addition of a couple of new Spring Boot dependencies that we added in. I'm going to go make a couple of changes to my POM file. First of all, every time you add the H2 database, it gives it a scope of runtime, meaning that you can only look at your data and only work with the database while your program's actually running. That is not what we want. So we comment this out. And really, it's interesting because everybody I know that uses H2 adds H2 through the Spring initializer like we just did, and the very first thing they do is they come and comment out this line. I don't know why it doesn't automatically not show up. That would be nice, but I'm sure they have their reason. We just need to come in and comment out that line. And then I need to check something. Hang on. Okay. We need to add one other thing to this, and that's the Jackson repository. And I'm going to go out and look that up. I don't have that in front of me, and I don't want to go search for it. So I'm going to go look at Maven repository, and I want to find the Jackson that we've been using, which I believe is Jackson Data Bind. And remember, this is the repository or the dependency that helps us convert from Java to JSON. And so I'm going to put that dependency in here as well. And I am done with my POM file. So great. All right, let's come up here and let's start working on some source code. So we've got our dependencies that we need. Let's come up here and start working on our source code to actually write this guy. Well, we're going to need a series of packages. And this is going to be very similar to the packages that we've done before. We're going to have a controller. I'm going to create, right-click, new package. We're going to have a model. right click, new package. We're going to have a service. And we're going to have another one called repository. This is the programming community is not settled on a name for this one. So I'm going to call it repos. This is the thing that allows us to connect from Java to our database. And you'll see it called repos. You'll see it called repositories. You'll see it called database access objects. All of those are exactly the same thing, just like sometimes we call them directories. Sometimes we call them folders. They're the same things. I'm going to use the term repositories most of the time, but you'll see DAO just about as common as you'll see repositories. All right. So I'm going to call that one repos. Like I said, sometimes I'll call it repositories. Sometimes people will call it DAOs. I'm sorry that we don't have a standard, but we don't. So that's going to be the structure of our program. Now, we need to come over here and we need to create a couple of things under our application properties. And one of the things we need to do, of course, is we need to set our port. And this is always the way we have been setting our port, which seems like a really good way to do it. And I've been picking port 2019 because I know I don't have a port 2019 running. So you can pick whatever port number you want, provided you don't have another system running on it. We are going to be doing a lot of conversion from Jackson, JSON to Java, Java to JSON. That's going to happen a lot. And there's one thing that we need to add, and that is spring.jackson serialization fail on beans is assigned false. So Spring Jackson serialization fail on empty beans is assigned false. And to be quite honest, that should be something that's set automatically, but it's not. And basically what it does is it determines what happens when there are no getters or assessors for a given type. So in other words, we run across a bean or an object that has no data. What do? We just keep going. If we run across a bean or object that exists but has no data, Jackson gets really upset and it will just crash. So from here on out, we're going to make sure we add this statement to all of our application properties. There's actually a movement to get this to be the default. All right, we have a couple of other things we need to add. We have added a database called H2. Well, with PostgreSQL we saw yesterday, we had a way to access it called pgadmin. Well, there's a thing called H2 console that we can use to access our H2 database, but we have to turn it on. It's not real safe to have it turned on, so you would want to turn this off if you put this into production, but for testing, it's incredibly helpful. So we add those two lines. And with that, we have our full application properties. We have our port set. We're making sure that if we have an empty object bean, that Jackson's just going to keep processing. And we've turned on the H2 console so we can see what's going on in our database. And I just posted that out to the channel. Now for some really fun stuff. We're going to start adding models. We're going to start adding classes that are going to represent our data. They are going to become the tables in our database. So let's do that. Let's see how that works. Let's create our restaurant first. So I'm going to come over here to model. And just like we've been creating a model, I'm going to go to new Java class, and I'm going to call this restaurant. Now, I want this restaurant is ultimately going to be a table in my database. So ultimately, I'm going to have a table in my database that represents restaurant, and also one that represents the menu items. So I just created a new model called menu. So a new class under the package model. Let's go deal with restaurant first. Restaurant is going to become a table in our database ultimately. Tables in relational databases are also referred to as entities. It's actually a throwback. Relational databases are really cool because they're based off of relational algebra. As a math teacher, I find that very cool. And you can actually use mathematical formulas to prove that your database is correct and sound and going to give you the right information and all that sort of stuff. Well, in relational algebra, we don't really have tables. We don't have classes. We have things called entities. And so we kind of use that term, to make us sound smart. This is going to be an entity, meaning that it's going to become a table in our database. And I want to give it a name. And I give it a name by using this thing called table. And notice these are all taken from JavaX persistence because they're databases, they're persistent data. And I want to give this guy a name. And I'm going to call it restaurant. I have found just through practice that when you create an entity, meaning you're creating a table for the database, you should always give the table a name. You should always specify the name. If you don't specify the name, and you'll see a lot of code where they don't, if you don't specify the name, it's supposed to derive it from the class name. Not all databases do that well, so I like to explicitly give my name. And I'll do that for all of my tables. To the point that I've had other people come in and look at my code and go, oh, you wrote that because I've listed the table. But I've had problems with that in the past, so I go ahead and list it. We need an ID. So we're going to have an ID. We're going to have a private, long, and I'm just going to call it restaurant ID. And every row in our table is going to have a unique ID. That's how we know that restaurant is that particular one. So when we were looking up this earlier, I looked up the Good Eats restaurant by going to the ID 12. So restaurant 12, there was only one restaurant 12, and it happened to be the Good Eats one. And we've been using IDs. We're going to let our database handle creating our ID for us and automatically updating our ID for us. So this is going to be an ID field. And the value that I want is going to be a generated value. And the strategy that I want to generate, I'm going to actually let my database decide. So what I'm going to do is this is going to be an ID, which makes it the primary key. So this is the unique thing for all the rows. It's going to be an ID. It's going to be a generated value. And by setting the strategy to be generation type auto, I actually let the database decide on what's the best way to assign that value. Now, they're always going to be unique. We know that. That's the ID forces that. Some databases have really bizarre ways of handling that, but we don't care. This is one of the things that allows us to write this as a H2 and then later, just with configuration change, switch it over to PostgreSQL. All right, this guy is going to have a name. When I create a name for my restaurant, there's a couple of things that I want to make sure happen. First of all, I want to make sure that I don't have restaurants with the same name. So I want to enforce a constraint that's called unique. So I put this at column, this annotation at column. And then what are some things I want to say about the column? Well, I want it to be unique and I want it to have something. You can't leave it blank. Nullable is false, meaning you cannot leave it blank. You can't leave it null. Two things to note here. First of all, notice I am not giving a name for each one of my columns like I did for my table, where I used an annotation at table to give a name for the table. For the columns, I'm going to use whatever the column, whatever the field name is, will become my column name. And I've had success with that, provided I do one thing. Notice that this is all in lowercase. And I keep my fields that are going to become columns, I keep them lowercase because I find that works on more different databases than like the camel case or something like that. So when you have a field that's going to become a column in a table, make sure the name is all lowercase. All right, let's add a few more here. Let's say that we're going to have an address. And with address, I don't care if they put one in. I don't care if two restaurants share the same address. The same thing with city. And I can't type today. All right. So that gives us the main fields. Now, we also know that we also know that restaurants can have a list of menu items. So restaurants can have a list, which is, I'm just going to make it an array list because those are the easiest types of lists to work with. Yes, there are other types of lists. We don't talk about them in this course. Those get to be kind of more advanced topics, but we're going to make this an array list. It's an array list of menus. Whoops, I didn't add the import for array list. And I'm just going to call this menus. Okay. Now I have a spot in my REST class to store its menu items. But the menu items are actually, in reality, going to be stored inside of this table called menu. So I need a way to connect my menu and my restaurant. Let's go over to menu. Let's take a look at menu real quick. Don't worry, I'm going to come back and I'll give you all this code in a minute, but I need to pop over. Actually, I'll give this to you right now. This is where we stand right now. We still have a lot more to do with restaurant, but that's where I stand now. Let's go to menu. And I'm going to do something very similar to what I just did with restaurant. So it's going to be an entity. It's going to have a name. And it's going to have a ID. And we're going to generate from now on, we're going to use this particular strategy to generate our IDs. Now we're going to have a dish, and we're going to have a price. And also, each menu item is assigned to one restaurant. So I need a way to store that one restaurant inside of menu items. And I'm just going to call it restaurant. Make one little change up here in that I want the dish to always have a value. So I don't want them to be able to leave dish null. I want them to actually put a value in dish. And so I'm going to set the column to be nullable false. I want to connect my menu item to its restaurant. Now, there are many of these menu items that can go to a single restaurant. Now, each menu item can only go to one restaurant, but we can have many different menu items going to the same restaurant. That's actually called a many-to-one relationship. So I put an annotation in here called many-to-one. So we have many menu items are going to one restaurant. Now, how do they get connected? Well, they get connected via a particular field in restaurant. And the only field in restaurant that we know is unique for a restaurant is a restaurant ID. So this says inside of menu, we're actually going to create a column that's called restaurant ID, and it's going to have the ID number of the restaurant that this menu item is connected to. Now, every menu item has to go to a restaurant. So I'm going to make this where it has to exist. So now we've connected this menu item to a restaurant. And yes, a join column is declaring a foreign key. That's exactly what it does, right? Good call. Let's go back to restaurant. Now we've connected menu to restaurant. Now we need to go the other way. We need to connect restaurant to menu. So in this case, we have a one-to-many relationship. So we have one restaurant that can go to many menu items. And so this is a little different. How are they connected? They are connected by restaurant. They're connected by a field called restaurant. Restaurant. That's how they're connected. So this restaurant and this restaurant are the same restaurant. That's how they get connected. Now, in this case, there is no column, there's no foreign key, there is nothing that's actually created in the database. When you do a one-to-many and a mapped by, that is something that Hibernate is going to need in order to keep up with our data. Now I'm going to throw a couple of things in here that are kind of advanced, but are very important. This says cascade all. What that means is if I ever come out here and I delete a restaurant, it will also delete all of its menu items, which makes sense because if menu items are tied to a restaurant, if a restaurant goes away, so should its menu items. And if I add a restaurant, I can also add menu items, which makes sense because that would be a good time to add menu items. Orphan removal should never come into play. But in case it does, Hibernate has a way to clean up after itself. What orphan removal means is what happens if we have a menu item that is not connected to a restaurant? Well, it'll get rid of it. Now, that should never happen, but just in case, Hibernate will go on and get rid of menu items that are not connected to a restaurant. Wow, we have now set up the fields for our two methods. So what I want to do is I'm going to give you these two. We're not done with these, but they're pretty close. So these are our fields for restaurant. And then these are our final fields for menu. And what we're going to do right now is we're going to give people a chance to get caught up with those. And we are going to take a 5-minute break. And when we come back, we're going to add getters and setters and constructors and all sorts of things, and then start working with the data that we need to actually use these models. But right now, let's take a 5-minute break. Okay, before I get back into this, um, out on the channel, I wanted to point out, and I don't always point this out, but I do read what you're posting, and if there was something that wasn't right, I would chime in. But there's this small thread out here going about the join column and the foreign key. If you haven't looked at that, do so. Some good stuff under there. Thank you. Just wanted to point that out. There's some good stuff that gets posted in the channel. So if you're not periodically just scrolling through the channel, reading what's there, you're missing out. All right, let's get back to this. So we have created our fields. Well, once we have our fields, we can start doing some important things. Let's do our, let's start with the constructors. So I'm going to right click, go to generate constructor, and we need the default constructor. And I'm going to create my own constructor. And with my own constructor, I am not going to include the menu list. So I'm going to leave that out. I'm just going to include the base fields for my restaurant. Then I need to generate getters and setters. So let's generate getters and setters. I'm going to right click, generate getters and setters, and I'm just going to do it for all of them. Now our ID, we set in the constructor, so we really don't need a setter for the ID. It's not wrong to have it in there. I just don't think I'm going to be using it, so I'm going to comment it out, and if I need it, I can put it back in. I think that looks good. I think that actually finishes out restaurant, at least for now. So we generated getters and setters for everything, and we generated a default constructor and another constructor minus the menus. All right, let's go look at menu. I bet we're going to do the same thing on menu. Okay, cool. Let's do with menu. Let's do the constructors first. So generate constructor, the default, generate constructor, and this time we're just going to use all of them. And then we need to generate getters and setters. And I'm just going to do getters and setters for all of them. And then again, just like we did before, I'm going to comment out the ID. If you don't comment out the ID, that would still be correct. There's actually some projects we do where we need to set the ID directly. So that is just based off of what you need. So we've generated constructors, getters, and setters. This is our model. When we run this thing, this is actually going to become the model, the schema, the tables and columns that are set up in our database. We're going to need some way to access it. Let's create that next. So under repositories, also called database access objects, we are going to create these things that allow us to connect Java to our database. And we're going to have one for each model. And they are actually interfaces. So the first interface I want to create is I'm going to create one for menu. And I'm going to call it the menu repository. Like I said, there's a lot of people that would call this menu DAO. They're both correct. I'm going to call mine repository. What menu repository is going to do is it's going to extend. I know normally with interfaces we implement, with these we extend, because the thing it's extending has quite a bit already built into it. It's called a CRUD repository. See, we're doing a CRUD application, so we need a CRUD repository that makes sense. And there's a lot of information that's already been implemented inside of this CRUD repository. This CRUD repository, it takes the JPA, the Java Persistence APIs, and using Hibernate actually implements them. We're extending it because menu repository gets all the good implementation from it, plus we can add our own stuff. All right, with CRUD repository, we have to tell it which model does this go to? Well, it goes to menu. And menu does have a primary key, does have an ID, and its type is long. Now notice I put long with a capital L. What goes inside the angle brackets right there have to be classes. And so this has to be of the class long, not the type, the built-in type long. It has to be of the class long. Don't worry, they work very well together. They know each other, so it's all good. That's it. That's all that we need to do to connect Java to our database. All right, let's do the same thing for restaurant. We want to do one of these repos for each model that we have. So let's do another one. This one I'm going to call restaurant repository. By the way, there's nothing magical about what I call this. It's just another interface. Just restaurant repository makes sense. And it is an interface. And if you're like me, quite often you forget to change that to interface. You can just come over here and type in interface. So if yours said class when you got out of there, you're going, oh man, that was wrong. Well, you can just change that to interface. It doesn't matter whether you generate it or type it in. It does the same thing. Again, we're going to extend the CRUD repository. This goes to restaurant, and restaurant has a long. There's a lot of methods that get exposed. That means we can use them. There's a lot of methods that get exposed by default, but not all of them do. One of the things we can do is if there's specific methods that we know we want to use that aren't exposed by default, and how do you know? Well, you'll just get them by practice. You'll see when we get down to the next thing that we do, how this all plays out. So bear with me. But right now, we need to expose a particular method called find by name. Now you'll notice that as I was typing that in, you'll notice that while I was typing that in, it did some auto completes for us. Most of the time, when I put something inside of this interface repository, I need to make sure that I can find it, that it's something that's actually built in that I'm exposing. So I'm going to make sure I pick it from the list. If you're putting something inside of one of these repositories and you're not picking it from the list, 99% of the time, you'll get it wrong. So make sure if you're putting something in here that you pick it from the list. You don't just type it in. And I'm going to send this, and I can send it anything I want, but I'm going to send it an actual string. That's going to be the name of the restaurant. What this is going to allow us to do, this isn't something that is primarily used, but if we want to, we can expose it. And that's what this is going to do. This is going to let us find a restaurant by name. All right, let me give you that. And then I want to address a couple of questions that have come up. So that's it for our restaurant repository. Now, we will get a lot more, these repositories will get a lot more involved as we do more, but for right now, this is pretty good. So a couple of issues. Let's do something here. I don't like the way my code looks. Okay, good. All right. So one question is, why is this long? And that could be, why is it long instead of an integer? And why is it a capital L instead of a lowercase l? Well, it's a capital L because this requires a class to go here. So we use the class version of long instead of the data type version. Why did I use a long instead of an int? There's actually two reasons why I use a long instead of an int. One is long class and long data type work very well together. They actually are pretty much interchangeable, whereas int and integer are not. The way they've implemented the integer class, it makes it a lot clunkier to work with. So I prefer long. That's one of the reasons. The other is long will allow us to have about as many rows as we're ever going to want. And so we don't have to worry about running out of ID numbers, whereas int is a much smaller number and we could run out of ID numbers. So, but to be quite honest, especially in the programs we're writing, the main reason that I do it is because long and long work very well together. And int and integer do not. This CRUD repository lives inside of this dependency right here. So when we started this thing, we added not only web and dev tools, we also added JPA and we added H2. And it's this JPA dependency that contains the CRUD repository. Okay. Okay. Let's now, so we've got our model. We've got our data. We've got our connection between our data and our application. So we've got our data. We've got our connection between that data and our application. Now, how are we going to enforce our application rules, our business rules? Where do those go? That's what we're going to do next. Let's go look at a service. It's a service is where we would, this is the service is how we add our business logic from when we're going from the data all the way out to the client, it's the service level that we really have the most control over. And that's where we're going to put most of our work, is going to go inside the service layer. The way we do this is we create an interface that we need. So let's create a restaurant service. And that's going to be interface. Now, everything that we want to do with a restaurant is going to go in here. Well, one of the things we may want to do is we may want to find all restaurants. So we're not sure how that's going to look yet. We don't really care. Right now, that's one of the things we may want to do. We may want to find restaurant by ID. And in that case, that particular method would return a single restaurant, not a list of them. And we would obviously need the ID to actually do that. And to be quite honest, how did I know these are the ones that I want? Well, I've already written the project. Quite often, we would leave this blank and just fill it in as we need them. But I just happen to know what we need, so I'm going to put them in up front. And this is actually a very common list. So if you take this list when we're done here and you use it for all of your applications, you're going to have a real good start. So we do a find all. We do a find by ID. Let's do a find by name. So quite often people will know the name of their restaurant. I mean, that would be normal. I would worry about people that would actually know the ID of the restaurant. Yes, what I really want to do is find 5670 instead of, I really want to know where McDonald's is. I think they're more likely to look up McDonald's. We're going to want to delete. Sometimes restaurants close. We actually had one of my favorite restaurants in town here close not too long ago. The guy retired. And so Bushwhacker is no longer. They had one of the best salad bars that I've ever had. Had these great marinade. I'll move on. Okay. So one of the things we may want to do is delete a restaurant. We may want to create a new restaurant, or in the terms that we use is save. And we may want to be able to edit a restaurant or update its information. Now, when we update a restaurant, not only do we send it the restaurant data that we want to update, but we also have to tell it which restaurant we're updating. Okay, now's when I have to add, Patrick, thank you, but you reminded me of Leslie's Fried Chicken in Waco, Texas, where I went to college. It got to the point where like they knew me by name. So yeah, it's wonderful. Okay. So this is the interface that we're going to use, and that's it. And this is actually a fairly common interface to use when you're working with one of these things. And so this is restaurant service. And this is what I'm using here too, is a pretty normal naming convention where we'll call this restaurant service, unlike the repos where there's, probably as many different names as there are programmers. The services are pretty normally named this way. So we've got the model service, and now we're going to implement it. So we're going to come over here, we're going to create a new package, and this time we're going to call it restaurant service impl. We're going to implement the interface. All right. This is where the majority of our work is going to happen. The first thing I want to do is I want to make sure that people know, our application knows that this is a service, meaning that Spring is going to load it up in the background and then it can be used across the application. So it's a service. And when I set it up as a service, I want to make sure that Spring calls it my restaurant service. And a service is something that's running in the background that is accessible to all of our other parts of our application. We've had something similar when we did the controller advice, but it was there, but it was only available to controllers. A service is available to everybody. Now, this restaurant service impl is going to implement the interfaced restaurant service. And you'll notice that we need, what does it say? Must either declare abstract or implement. Oh, we haven't implemented the methods yet. Oh, well, let's do that real quick. Right click, generate, right click, generate, override methods. And I want all of the methods that are related to the interface. So that's the ones down here. Now, there are all these methods related to an object that you could override as well, and we might, but right now I just want the methods that are related to my interface. Now, that actually puts the methods in there for us with all the correct headers and everything. They just don't actually do anything. We're going to have to come back and fix that. So like I said, this is the services is where the majority of your work is going to go into. All right. The service is going to connect to the database through the repository. The repository is going to bring in the data for us, and then our service is going to manipulate that data somehow and either send it back to the repository or send it to a controller, which is the thing that connects to the outside world. So one of the things in there is this guy does need access to the repository, and I'm just going to auto wire it in. And I like to call these a little abbreviation. So like this is the restaurant repository, so I'm going to call this rest repos. So we are overriding all of these functions. Actually, we don't need to override them because the base function up here doesn't have any implementation in it. You can, although we very seldom do, it's real popular in libraries, but in applications, it's not very popular, to have actual code inside of an interface. It's just standard practice to override it, to say you're overriding it. But I believe, although it's been so long since I've tested it, I believe we could comment out the overrides and we would still be in good shape. But it is common practice when you're working with an interface to override the thing that's over there, just in case someone goes in and puts some code in there. You don't have to worry about it. You're creating your own. Wow, we have the structure now in place. And our next step is to actually start implementing this. So that's the structure that we have in place. What I want to do at this point is we're ready to start doing, we're now after what, an hour and 15 minutes, we're ready to start doing the real work. Yes, this is where the fun stuff happens. Let's take a 5-minute break, and people that need to can get caught up there. And when we come back, we will start actually doing our business logic of finding all, deleting, and all that sort of thing. So let's take a 5-minute break, and then we'll fill out the service. Okay, so what we're going to do is each one of these services, each one of these methods in this service, we are going to eventually use in the controller somewhere along the way. And we need to make use of the methods that are in the repository. And sometimes the repository methods return things rather interesting. And so we're going to have to do some conversion to get them to something that we are used to working with. All right, let's take a look at the first one, the find all. So we want to go through, we want to find all of the restaurants. Okay, well, let's create a list, array list of restaurants. So I'm just creating a list that can hold our restaurants. And I'm just going to call it list. I'm going to be real original here. All right. So there's an array list to hold all of our restaurants. And by the way, that's the thing we're actually going to end up returning. We're going to end up returning list. Now, we're going to call, we use the repository then to get our data. And in our repository, you can see we've got all sorts of methods that are already available to us. Notice there's one here that's in bold. That's the one that we specifically opened up for us. Find all. Find all returns a iterable. Okay. So we haven't done any work with iterables, maybe a little bit, but nothing that, and we don't really want to worry about processing iterables. Really, the best bet is to get an iterable, put it into an array list, and then use all of our cool stuff with array list. So that's what we're going to do. Here's how this works. We want to iterate through our list. So we get an iterable back, and we're going to iterate through our list. And that's the string of methods that you use to do that. And what I want to do is for each iterable, each item that comes out, I want to add it to my list. And there's actually a shortcut way to do this. So what we just did here is we called the REST repo to get the data. We did a find all that's going to return all of the restaurants. We know it's the restaurants because we went to REST repo. We return all of the restaurants. They get returned as an iterable. The way we convert that iterable to an array list, which is something that we're used to working with, we call a method called an iterator. And then we loop through that iterator doing a for each remaining. And then this is a shortcut to say, add each one of those items to our list. And then we return that list. And that gives us an array list, which is what we're used to working with. And then that gives us all the fancy stuff we've had with array list, with sorting or filtering or any of that kind of thing. It's a real common way to do a find all. And what I would do if somehow I needed to edit this list before I returned it for some reason, I would do this, and then I would loop through the array list and do any editing. But what I do is I just make sure I put this into an array list as quickly as possible, and then I do all my work on the array list. All right, let's come down here. Let's look at another one. By the way, none of these are going to be easy. Or I should say, none of these are going to be straightforward. Let's look at this one. This one's kind of interesting. We're going to go to the repository again, and this time we're going to do a find by ID. Now notice a find by ID returns this optional. It's nice because an optional can be any class we have. It's not a problem. It'll return any type of class that we have, but we want a restaurant. We don't want some generic class. We want a restaurant. So how are we going to make this into a restaurant? Well, okay. So here's what we have here. We have the restaurant repo, does a find by all, and returns an optional. Optionals have a bunch of cool methods attached to them. One of this is this or else throw. So what happens here is we do this find by ID. If it doesn't find it, it will go to this method called or else throw, and we're actually going to throw a new exception called entity not found. Now, the entity not found exception is built in. We didn't have to create it somewhere. And it takes a string as its parameter. So what I'm going to do is I'm going to create a new entity not found exception, and I'm going to send it the ID number that we were looking for. Otherwise, if it doesn't get down here, it just returns that optional. Well, Java does a typecast from optional down to restaurant, and it can do that. And that's how we convert it to a restaurant. We let Java do an automatic typecast. Up here, we couldn't do that. You can't go from an iterable typecast to an array list. So we had to go through some steps, but you can go from an optional down to a restaurant. This is a Lambda expression without any parameters. So I don't put anything here. And what it does is it creates a new object of type entity not found exception. And then we could handle entity not found exception in our exception handling. Now, we're not going to do any exception handling in here. We're just not going to have any time to do that. But we could. And we could handle entity not found. And we'll talk about some other ways to handle that as we go along. Let's look at find restaurant by name. Remember that we have this find by name, and find by name is going to return a restaurant for us. It's actually returning something of the class restaurant, and it requires a parameter. Okay, so let's do this. Let's do a restaurant. So what I'm going to do is I'm going to create this object called restaurant, and it's going to be of type restaurant, and it's going to be whatever this returns. And that's ultimately what I'm going to want to return from this method. Well, what if we give it a name of a restaurant that's not there? Well, if If that object is null, meaning we did not find the restaurant, we're going to throw a new entity not found exception. And this time, I'm going to give it a little bit more of a detail. I'm going to say restaurant plus name not found. That will end up being the message then that will show up if we can't find the restaurant. All right, let's delete. Now we're actually moving on. Up till now, we've just been looking up the data. Now we're ready to move on to actually make changes to the data. So let's do that. This is our first one. We're going to delete. What we want to do is we want to find the restaurant first. So we don't want to try to just delete it, because if it doesn't exist, that could be a problem. We have to make sure it exists. So let's find it. And then if it's there, we're going to delete it. If not, we're going to throw an entity not found exception. All right, let's do that. So if, and we'll put something in there, and if it is true, we're going to want to delete. Now I want to show you, we actually have a delete by method. And I want to delete by the ID. Now, if we didn't find it, remember, we want to throw a new entity not found exception, long toString ID. And this isn't returning anything. A delete doesn't return anything. It just does something. So we don't have to worry about a return. But how do we know if we found it or not? Call the repo. Do a find by ID, which returns an optional. And I said the optional has a lot of cool methods that you can use after it. One of those is present, which returns a true if we find it. It is present. Or it returns a false if it doesn't find it. So we can take advantage of that is present to see if it's true. If it found it, then we could delete it. If we tried to delete something that wasn't there, this throws an exception on its own that will cause our program to stop running. So we don't want that to happen. Yeah, we could trap the exception using a try catch that we talked about last week, but this is the more normal way of handling this. So we do a find by ID, see if it's present. If it is, we delete it. Otherwise, we throw this entity not found exception. Most of the methods are coming from anything that ends up after this REST repo is coming from CRUD repository. Yes. And CRUD repository is the thing that's actually responsible for deleting the data from the database. It has all the database code in there that actually goes out and does the delete from table where ID equals. It's got all that implemented in there for us. We don't have to worry about that. All right, let's create a new restaurant. Now, when someone sends us a restaurant, we're just going to add it. Okay. So they're going to send us the data for a restaurant. And they're going to send it to us as a JSON object. So this is like what we would get if someone was going to create a restaurant. So we have a JSON object that has the single fields for the restaurant, and then it could have a list of menu items after it. All right, so how does that work? What we're going to do is we're going to come in here and we're going to create a new restaurant. So I'm going to create a new object called restaurant. And then I'm going to put the data from this restaurant that's coming across. It's not exactly in the format that I want it, especially with menus. And I want to make sure that it doesn't have any ID number. So I'm going to create a new object. I'm going to put the data from the object that we get sent into this new object, doing any manipulations that I need. And then ultimately, I want to return that object. And I do that by saving it, because I want to save it as well. So the save from rest repo.save, it actually returns the object that it saves, including the ID number that got added to it. That's very important. And so that's the object, the restaurant object that I want to return. But now how am I going to go from the restaurant object they sent us to this new object that I'm going to save? Well, I'm going to use my getters and setters. I'm going to have a name, right? So I'm going to set the name, and the name that I want to set is from the name of the object they sent us. So I'm using my setters and getters. And this is the new one that we have, and we're getting the name from the one they sent us. Here, I will save us a little bit of typing. This is the rest of those. Actually, I think I included name as well, didn't I? So here we're setting the name. We're getting the name from the restaurant. Notice the one thing that's missing here is ID. Even if they sent us an ID, I'm not going to use it. I don't want to. It makes no sense. So I just set the ones that I want, leaving ID to be null. That's fairly straightforward, and that we really don't need the other object for. Menus we do. Menus are fun. Let's add some stuff for menus. For menus, what we're going to need to do is we've got this list out here of menu items, and we need to assign them to this restaurant. So what I want to do is I want to go through this list of menu items that we have. So I have a list of menu items, and they're actually stored in this thing called get menus that is coming to us inside of restaurant. And I want to assign them to the new restaurant. And if I had done something like this, if I had just taken this menu, this get menu, if I'd done this, new restaurant dot set menus restaurant, which would make sense. I mean, this is the way we did all the other ones, right? So why can't I do it this way for here? Okay. That does a great job of storing the pointer of get menus inside of set menus. And now set menus has a pointer to something that doesn't exist. It does a great job of setting the pointer to the list, but it doesn't actually put the data in there. Well, we actually need the data, so I have to go through this loop. So I can't do that. I have to go through a loop because I actually need the data, not just the pointers. What I want to do is to the menu list for the new restaurant. I want to add a new item. I want to add a new menu item. And what I want is the dish, the price, and I want to assign it to this restaurant. So remember when we created the constructor for a menu, we had the dish, the price, and the restaurant it goes to. We're creating a new item. We don't know its ID. We're going to let our class set the ID for us. We have a dish, a price, and the restaurant it goes to. At that point, we now have a complete restaurant object that we can save. This REST repo handles not only saving the object, the restaurant object, but it also handles creating and saving the menu items. We are adding this menu item to the restaurant's list of menus. So we first have the list of menus. So what's the list of menus? Which field in the restaurant has the list of menus? Well, it's menus. So we do a get menus. That tells us the menu list for this restaurant. And then we want to add a new item to it. So we can't add it directly to the restaurant because the restaurant is not a list. The restaurant is just this object that's sitting out there. We need to add something to its menu. And so the menu, we're going to add this thing to it. We're actually changing data right here. And we're changing data in two different spots. Not only are we adding to restaurant, we're also adding to menu. When you're changing, especially when you're changing two different areas, you need to use this annotation called transactional. And notice that there are multiple places that have an annotation transactional. We want the one from Spring Framework, and it does really matter. So transactional, what that means is we're going to have this entire method run. And if any parts of it fail, whether it's adding to the restaurant or adding to the menu, everything's going to fail. So it's not like we can add a restaurant without its menu list because the entire process would fail. That's what transactional does for us. It treats this as if it was one big command, where we really know it's multiple because we have one for restaurant and then one save for each one of the menu items. Updates are weird. Um, so I'm ready to move on to the updates. So updates are weird. And the problem with updates is there's actually a debate that goes on in the industry about when you update an object through a REST API, do you have to send it only the items that you want to update? Or do you have to send it all of the items, even if you're not updating them? And you have people that are zealots on both ends. And so I've decided to go with, to show you how to do the one where you only have to send the item you want to update. Why am I showing you that one? Because the other method where you have to send everything is almost identical to a save. Now, this method, I'm just going to give you the code and then we're going to walk through it because it's a lot of typing. It's very, very similar to the save. So this is that entire, I'm just going to replace this entire method with what I just posted in the channel. And here's the deal. We're going to update. When we update, they have to send us the data they want changed and the ID number of the restaurant they want to change. We see if we actually have that restaurant. If we do, great. If we don't, we throw an exception because there's nothing for us to do. Then we run through each one of the fields. We do a get for each one of the fields of the thing they sent us. So if the thing they sent us is not null, meaning they sent us a new name for our restaurant, then we replace our current restaurant name, just like we did up here. The big difference here is we check to see if we actually have it. So if they actually, because we're doing an update, if they actually sent us a name, then yes, put that new name into our current restaurant. If they actually sent us an address, yes, put that new address into our current restaurant. And if they didn't send it, we just leave it whatever it is, whatever its current value is. And we do that for all of them. The trick comes down with menu items. And the way this works is if what they're sending us, if they actually send us menu items, we're going to take a look. If I'm remembering right, this will actually, you have to send us all of the new menu items that you want, you have to send us all of the menu items that you want, both old and new. And if you don't send us any, then we don't update it at all. In most of the systems like this that I've seen, if you want to actually update like the menu items, there would be a separate endpoint to update those. You wouldn't update those at the same time that you're updating a restaurant. So this wouldn't really come in play very often. But if they do send us anything, we actually replace what's there and put this in its place. When we get to actually a controller and running this, we'll run it, we'll see what happens, and we'll go from there. Um, we'll take a look at that as we go on, and then we can come back and see what we actually end up with when we work with our menus. Okay, let's compile this. Or let's rebuild our, I'm just going to go to rebuild the project. Let's see. Oh, it looks like I have an extra brace in there. Okay. Okay, great. So we have done the database, how our data is going to look, the way we're going to access our database, and then our business logic to access the database. And you're right. I'm not liking my little thing down here that I put. I want to see what happens at the end. So I'm just going to push that off. All right. We still have one major part that we need to work on, and that is the controller. And there's actually quite a bit inside the controller because remember, not only are we looking up things, we are also deleting, adding, and updating stuff. So we have the full CRUD operations going on. So there's actually quite a bit in the controller. I know we have 10 minutes left in class. Here's what's going to happen. I'm going to go through and explain the controller. If that ends up running over 11 o'clock, I'll say I apologize up front. But when we get to 11 o'clock, I understand that we have lives and you may have stuff scheduled at 11 o'clock, which is fine. So if we get to 11 o'clock and we're going to run over, you are welcome to bow out at that point, to sign off and go do what you have to do at 11 o'clock. It's 11 o'clock Lambda time, by the way. And then, you could come back and watch the rest of the video later on or something like that. We'll have some stuff covered before that happens. But I don't want you to feel obligated just because I couldn't get everything done in the 2 hours. You shouldn't feel obligated to sit here through your lunch hour. So feel free at 11 o'clock to sign off if you need to. And like I said, you can come back if you need to. You can come back and pick up the video. I will, of course, when I'm done with all this, provide you with the code. All right. That said, let's get started working on our controller. We're just going to have one controller. We can have as many as we want, but we're just going to have one, and I'm going to call it a restaurant controller. All right, it's going to be a REST controller. And I want all of my endpoints to start with restaurants. What I'm going to do is when I need to access data from the restaurant, I'm going to use the restaurant service. So I'm going to auto wire in the restaurant service. The only thing that's going to the only thing that's going to access the repository directly is going to be the service. Everyone else should be working through the service. I said typically, if we're using some C data, which we'll talk about in a minute, if we're using some C data, sometimes it uses the repository. But our main application should always work through the service. All right, let's take a look just at a get mapping. And let's do the one where we return all of the restaurants. So we're just going to do a get mapping where we return all of the restaurants. I didn't do something. I'm going to cycle back over here and do this. I didn't give you, we have finished this restaurant service and I didn't give you the final code. So let me do that. So what I just posted out there is the final implementation of our restaurant service. Let's come up here to restaurant controller. And of course, this is going to produce JSON. It's going to be a response entity, just like we've been doing. And it's going to be list all restaurants. Okay, so up till now, it's pretty much the same thing we've been doing. Let's do an array list of restaurants. We'll have to call it something. I'll call it my list. And we just want to do a find all. It's going to return a renew response entity that's of my list and a status that says everything is okay. Now, this is similar to what we've been doing because the controller doesn't change. The controller, which is our interface to the outside world, should actually be very small. Most of our work's going to happen inside of our service. And so here, we're just calling the service find all, and whatever it does, we know at the end of the day, it returns an array list to us, and we spit that array list back out. And so that's not unlike what we've been doing. And just like we've been doing, I've just posted some stuff in here, and I posted it in the channel as well. We do another get mapping, this time for the restaurant ID. And we get in the restaurant ID. We do a find restaurant by ID, and that is something that we have implemented over here. Find restaurant by ID, and it returns a restaurant. We don't really care how it finds the restaurant. We know it returns one for us. And so we just use that then and return it. So again, the majority of our work is happening inside of the service. So we don't have to do any checking for resource not found or anything like that. All that now has been pushed off to the service. The same thing with the find by name. It's exactly the same process, but we use name instead of an ID. All right, let's do a delete. We're going to do a delete mapping. That's the easiest one to do. So let's start with the delete. So we've got our gets. So in CRUD, we've got our R. We're now going to add our D. And in this case, we're going to go the endpoint that we want is actually the same endpoint that we use to get a restaurant. But that's okay because our methods are different. Our HTTP methods are going to be different. This was a get. This is a delete. And over in Postman, there's a spot over here to pick what your HTTP method is that you want. I just want to warn you, it's 11 o'clock. I am going to keep going, but like I said, seriously, if you have something else to do go do that. And I want you to know, I feel bad. I'll be working on cutting this down for future, but for right now, do feel free. There's a brown bag open. There's some other stuff going on. Do feel free to switch over to that. I certainly understand schedules and having lives, but I'm going to keep going. And you can always come back and watch the video of this later if you want to, but of course I'll give you the code as well. All right, so let's delete. Public response entity, it's always that. And we give it some name. Delete restaurant by ID. And we have to give it, just like we did before, we give it a path variable that's of type long. That's a restaurant ID. All right. So that's almost identical to what we did when we did a get. There's two big differences. One is we're using a delete instead of a get. And two, we don't have any produces JSON. And the reason is a delete doesn't produce anything. A delete's going to send back absolutely nothing. So there's nothing to produce. But now how do we do a delete? Well, we do a restaurant service dot delete. And it takes an ID. And now we are returning a response entity. And the reason that we return a response entity is we have to let our client know that everything's okay. Now, if for some reason everything's not okay, we would have thrown an exception inside of delete over here in our service. We would have thrown an exception over here. And so we would never get to be able to return an okay. So that's a delete. Very similar to a get. Let's do a put. Now, a put, remember, is an update. You post new items, you put changes to those items. So let's do a put. A put is almost identical to a delete. In fact, I'm going to copy the delete. And I'm just going to go through here and make a couple of changes. So a put is almost identical to a delete. A put means Updating, yes. Okay, so instead of delete, it's a put. Instead of delete restaurant, it is a update restaurant. Now, there's actually two parameters that an update needs. There is the ID number of the restaurant we want to update, but there's also the body. There's the information that we want to update. So we're going to get in what is called a request body. And it's going to be of type restaurant. And I'm just going to call it update restaurant. So what we get here with an update, we get two different pieces, two parameters. One is a parameter that we'll see on the URL. That'll be the ID that we want to update. But the other is this body. And at the very beginning of class, I quickly showed you how that plays out. We'll look at it again. But inside of our request, our REST API request, we can send a request body, which is a JSON object. And in this case, it's a restaurant JSON object. So we need to call update. And with update, not only does it need the ID, it also needs the actual data that we sent in. And then we just return back something's okay. So we don't have a create yet. We have a read, an update, and a delete. Let's do a create. It's by far the hardest of the ones that we're doing. And it's also the last one, the last endpoint that we have. So let's do this. Let's do a delete. And I'm sorry, let's do a post. Let's do a post. Post, let's add. Let's save. Now, a post is interesting because it does actually two things. One is it consumes it can consume JSON because we're going to send it the new information, but then it's going to return some information back that's going to be of JSON format as well. So it can consume and produce JSON. And now that I'm looking at this, I forgot to say that our put, and again, this is just for documentation, but it's important documentation. Our put consumes JSON. So I went back up here to our put, and it consumes JSON, that being the request body that's coming in, and it's coming in a JSON format. Okay. Public response entity. Imagine that. Add new restaurant. Okay, I didn't do this for the update. It's not a required thing, but it's good practice to throw it in. When we get in a body, all right, we're going to do something like that. And we're going to get in a body, a request body, that's going to be a JSON object. And that's the thing we're going to add. Now, before we actually try to work with that object, we want to check to make sure it is valid. And there's actually an annotation called @valid that checks prior to using this request body whether the data that's in there is valid. By valid, it looks at the model, and it says, oh, look, we have this @ column, so dish cannot be false, cannot be nullable. So if it gets in a JSON object for a menu that does not have a dish name, it throws an exception saying, hey, this isn't valid. Restaurant, remember the name of our restaurant had to be both unique and it had to be present. So again, if valid finds out that this is not a unique name or it is not, or it doesn't exist, it's going to throw an exception. Now, why would you not want to do that? That can get to be kind of time consuming. And so you do take a performance hit checking whether it is valid or not up front. Well, first of all, let's save our new restaurant. Well, that was easy. But it is common when you create a new resource, when you create a new object like this, it is common to, in proper practice, to return in the header a link to the new object. We saw that at the beginning of class, but we need to create a link. So we've just created a new restaurant. Well, how in the world is the client supposed to find that new restaurant? In other words, what is the restaurant's ID? Well, here's how we go about doing that. We're going to set the location header for the newly created resource. Okay, so let's create an HTTP header. And again, this is all within the Spring framework. So HTTP headers, and I'm just going to call this the response headers. And this is the stuff. Come back, little fella. When we get something back, we have a header that we get back, and I'm going to start putting stuff in here. That's the point of what we're doing. So we create a new header. Now we want to put something in there. And what we want to put in there is the URI. Actually, it's going to end up being a URL. Most people actually nowadays tend to use those interchangeably. But we want to put basically what's the endpoint where you can find this new restaurant. And so we want to build this new restaurant, and how we want to build it. We want to build it from the current request. Get the path of the current request. All right. By the way, I would never try to type that line in from memory right there. I would always go and look that one up. So, what we're doing is we're creating the URL where we can find the new restaurant, and we basically build the path, getting the ID that got created when we did a save, getting that ID number and putting it inside of the path. And then at the end, we return all of this. There's no body that's going to get returned. There is a response header and there is a HTTP status. And this time we're actually creating something. So we're going to use an HTTP status of created. Now I want to rebuild my project. And I'm done with my controller. So there is my restaurant controller. Now, in order for all of this to work, I need some data to work with. So I want to have some C data. I want to have some data that I want to load up first in order to get this to work. Well, I've actually written a package for us, a class for us that will create C data. And I'm going to give that to you. For your afternoon project, you're also given some C data. So I'm going to come up here and I'm going to create a new Java class that I'm going to call seed data. And notice it's at the same level as the application. So it's not inside any of the sub packages. There is probably as many ways to create seed data as there are programmers. I just happen to really like this particular method. So this is my seed data. Now, you may have to make a few changes depending on what you called your packages. So these lines right here, actually, yeah, those lines right there, you may have to change slightly to fit with your package names. Everything else, though, assuming you kept everything named the same that I did, will work. We have this thing that's going to run that's called a command line runner. Command line runner runs before pretty much anything else in the system runs. So before we start dealing with our controllers, before we start dealing with a lot of things, we do a command line runner. And what I primarily use it for, and what most people primarily use it for, is to put seed data in. And so that's what all this is I've gone through and I've created a restaurant named Apple that has this long list of menu items. Eagle Cafe has a couple. Number One Eats just sells pizza. So we are done. We have our seed data. We have our application. Let's try running this and let's see what happens. That is not the error that I wanted. I wanted an error. That just doesn't happen to be the one that I wanted. One of the things that's really irritating about this point about spring is the stuff that's inside of quotes in these one to many to many, and a few other things. It doesn't always check to make sure that it's correct. In other words, if you misspell something inside quotes that's different from what's outside of quotes, sometimes they don't match up. And that gets to be kind of irritating. I don't think that's the case here, but it is something to keep a lookout for. So this is restaurant ID. Let me make sure that I spelled these the same way. Is the issue in the controller? Just didn't look that way, but it's quite possible. Yes, actually, when I first did this, someone told me that they were impressed that I was willing to try to spell restaurant. So you said that restaurant ID is misspelled in get restaurant by ID. Get restaurant by ID. You know, I can make that a lowercase, but I really don't think maybe they have to match. I know that much. And again, they don't do any checking for me. Let me try running it and look at the error message again a little more. This would actually be kind of fun if we weren't already so far late in class. Let's see. So we have an entity manager, the class resource, auto config. So there's a problem with our Hibernate JPA method. Okay. And it's an illegal attempt to match a non-collection inside of restaurant models, restaurants. All right. So in restaurants, this is a list, and I'm mapping it there. Oh no, don't tell me they're going to do that to me. Oh, perfect. Great. Hang on, I'm going to see if this works before I explain to you what's going on. Okay, great. Well, thought I'd try something and it didn't work. So when I'm creating this list of menu items, it's going to be an array list, right? But one-to-many doesn't work with array lists. One-to-many works with the next level up. So list. They don't work with hash maps. They work with maps. They don't work with hash sets. They work with sets. So we have to go one step up when we're creating these things, and we have to say that they're lists. We'll just keep that in mind going forward. Cool. Well, let's see if we actually can get some data out of this. Let's run this. And I'm on port 2019. Looks like everything's running well. Let's look up our restaurants. and we get a big mess. What's happening here is that when I said I didn't get the error message I expected, this is the error message that I expected. What's happening here is that when we go to put our restaurant out, we go to display the JSON of our restaurant. It also tries to display the JSON of our menu. That makes sense. Now, when we're displaying the JSON of our menu, notice one of the things it has is a restaurant. Okay, so we display our menu, we display our restaurant, but when we display our restaurant, it has a menu. So it's going to display menus, which is going to display restaurants, and we are now in this infinite loop of displaying restaurants, menus, restaurants, menus, restaurants, menus. We have to break the chain. All right. The way we break the chain is we do this. Let's go over here to restaurant. So I'm in my restaurant model. Well, when I am printing out my menu items, if I'm coming from a restaurant and I'm going to print out my menu items, I don't want it to print restaurant again. So I do a JSON ignore properties. So JSON ignore properties says that when this field underneath it is printing, do not print this particular property. In this case, it's restaurant. So that breaks the chain. So when we print a restaurant, it prints out the menu items, but it will not print the restaurant again. Let's do a similar thing in menu. So in menu, what's going to happen is that if I'm printing a menu and I go to print a restaurant, I do not want it to print its menu. Okay, let's see if that fixed our problem. So I added this JSON ignore property menu inside of menu, because if we're printing a menu and we print a restaurant, we don't want to print the menu again. Inside of restaurant, I added this restaurant JSON ignore properties, because when we're printing a restaurant, we don't want to print and we're printing a menu, we don't want to print a restaurant again. Let's try running it and see if that fixed our problem. So let's just get a list of all of our restaurants. Look at that. Now we get a nice list of all of our restaurants with their menu items. So we broke the chain of doing this infinite loop. Great. Let's try creating a new one. Let's try creating a new restaurant. So here's what I'm going to do. I'm going to go back to Postman. All right. So I'm going to create a new restaurant. So creating is posting. And we decided that the endpoint to create a new one is going to be localhost 2019 restaurant. And we want to send it inside of the body of our request. We're going to send it the data for the new restaurant. And the data is formatted raw JSON. It's always formatted raw JSON because we're working with REST APIs. And so that's the data that I want to send it. And that's going to create a new restaurant. And I've already gone through and I just posted it out to the channel. I've already gone through and massaged the JSON so that it's in the format that we need and all that sort of thing. And I'm going to hit send. And I got back absolutely nothing in my body, which is exactly what I was expecting when I created an object. Let's go look at headers, though. Why did I not get my header back? Body shouldn't have sent anything. I should actually have a header that tells me that I can go to this. I just happen to know. And it returns my restaurant for me. I just happen to know it's 12. But I've got to go see why our header didn't show up. But again, a nice thing about using an in-memory database, I'm going to stop this. That wipes out everything I've just added. And I can come over here and see what's going on with our header. And we can fix that and move on. Oh, yeah, that would help. Yeah, that would help if I actually finished the code. So I've done well with that, but I need to actually add my URL to my headers. So I'd created the URL that I wanted. I just never actually added it to my headers. So this is what we have now for our post. All right, let's try this again. I'm running it. I'm going to go to Postman. I'm just going to go to a new tab. I want to do a local host 2019 restaurant. I want to go to the body of this. It's going to be raw. It's going to be a JSON object. And I need to get my data. Which I've posted in the channel. And this is actually going to be a post. And I'm going to do a send. And it runs. Good. I get nothing back in my body, which is exactly what I wanted. I go to the header and notice now I have the URL that I need to find the object I just added. Cool. So we could run through a put. We could run through a delete. A delete would just be, it's the same endpoint that we've been using for gets. We just changed the method to delete. And now that new guy that we just added is gone. And notice it doesn't exist. I don't have all the fancy exception trapping in place. So a delete is you simply give it the ID number and it's gone. Let's quickly do, why is it listed twice? Oh, I remember. Okay. So one thing that I'm going to do is we had a question about what our about what happens when we send a new menu list. What I'm thinking happens when we're doing a put, so we're doing an update, and we send a menu item, it wipes out the current menu that's out there and puts our new menu list in its place. That's what I'm thinking happens, but I want to go through and verify and make sure that's correct. I'll do that offline and post to the forum. When I'm done here, the first thing that I'm going to do is zip all this up and send it to you. And then I'll work on posting the video. Let me just spend about 5 minutes talking about your afternoon assignment real quick. Your afternoon assignment is kind of like this, but there's a little twist. So in your afternoon assignment, you're actually going to have 3 tables. And you can read out here about what you need to do with those. I do give you the class for the C data. The other thing I'm going to do is I'm going to post in the channel under a thread that I'm going to call Afternoon Project Spoiler Alert. I'm going to post what I used for my models. That'll give you something to start with, but if you want to work on that on your own and then look at them to see if you run into problems and use them as a reference, you can. But I want, for some of you, I want to give that to you if you want to use it. If you want an extra challenge, don't look at them. So that's your afternoon project. Basically, it's what we just did, but we just had 2 tables, restaurant that had a list of menus. This has 3 tables. It has orders that has a list of customers. Excuse me. It has customers that has a list of orders. It has agents that has a list of customers. And so all of the one to many, many to one, and all that kind of stuff, that's why I'm giving you the models. So if you're struggling with figuring out what's correct on that, I'll give that part to you. But again, if you want an extra challenge, don't look at them until you need to. I appreciate your patience hanging with me. This was a long project, but it's really, we're finally, in my viewpoint, getting to do something fun. So now we're coming up with full applications. So thank you. I'm going to sign off. And if people need help, I see there's some chatter going on in the channel. If you need help, do reach out to me. Otherwise, remember, we do have a Q&A scheduled at 3 o'clock today. So it's optional. So hopefully I'll see you at 3 o'clock. If not, then tomorrow during class. Thank you.